Guided tour time. I gotta tell you, this is the prettiest Fender Bassman I have ever seen. I mean, this thing is cosmetically just beautiful, right? You'd almost think it had been restored, but I was told this is actually its original condition. Welcome to D-Lab Electronics. On the bench this weekend, I have a really nice Blackface Fender Bassman. Comes to me from a fellow in Fort Wayne, Indiana who runs a recording studio. The complaint is the amp has a lot of hiss and little pops and little birdies flying around in it, which makes it useless for recording. So we're going to investigate that, and then as an option I'm going to add a Master Volume on the back of the amp in the place of that old accessory AC socket that's useless anyway. So it'd be a great upgrade for somebody to run this thing at a lower power for recording. So here we go. So before we remove the amp from the cabinet and take a look at the circuitry, we're going to listen to the problem. So I'm going to flip around. And I've got this old vintage speaker here, which actually has a 10-inch Fender speaker in it. So I've got the volume all the way down. So you can hear a little bit of rumble there. Not too bad, but there is a noise floor. So let's give this thing a little tour so you can see the cosmetics. And then I'm going to get the chassis out. Ooh, there's a good one. Guided tour time. I gotta tell you, this is the prettiest Fender Bassman I have ever seen. I mean, this thing is cosmetically just beautiful, right? You'd almost think it had been restored, but I was told this is actually its original condition. So let's pan across here nice and slow. Very well maintained. You can tell this thing has not seen any action in bars. Nobody spilled beers on top of it, right? Okay, let's flip it around, look at the back. Here we are backside. Now this amp has been retubed. Got some nice tongue soles in it. As you can see, it has a back cover, which most of these are missing. So let's pop the back and take a look at the chassis. So the back panel is removed. You can see those new output tubes I was telling you about. Transformers all look original. Covers on the capacitors there, right? There's the tag. And then down here I noticed there's some print on the cabinet. Some stampings there. And this is the model, AB165. Alright, I've got everything undone, ready to pop her out of the chassis. A lot of these are pretty tough to get out, but this one here is sliding right out. And there she is. Alright, let's pan the inside of this baby. This thing is super clean. There's no dust. You can see there's been a little bit of maintenance done. Some upgraded capacitors here and there. But all in all, she looks pretty stock. I noticed that this tube socket here appears to have been replaced. It's not the brown series like all the stock ones were. So we'll check that socket and make sure it was a decent quality. If not, we'll replace that. But man, this thing looks great. So now I need to give it a little thorough inspection using my magnifying glass. So I almost forgot, before I break out the magnifying glass and do the Mr. Obvious inspection, here's the top side. Super duper clean, man. This thing's going to be a lot of fun to work on. Alright, so as you know, always give these things a real good inspection using my lighted magnifying glass. And that helps me to identify if I see any cracking on connections on these eyelets. They usually are pretty obvious. Now this thing is full of the old CBS 10% value resistors, which is kind of a bummer. Those are kind of known for generating noise. And I also noticed these guys, these old red caps, and they're kind of known for leakage. And the other issue, and I know a lot of you guys may not agree with me on this, is these old Ajax .022 microfarad caps that go to the grids of the output tubes should be changed, because if they have any leakage, which old caps always do, those guys can damage your output tubes. So I'm going to change these, but I will give them back to the owner. Here's a close-up on those red caps that I told you that I'm going to change. These are 0.1 microfarad at 400 volts. Here are the grid coupling caps that should be changed also, because over time they leak, which will change the negative bias on your output tubes and possibly damage those. Okay, you can see that there are some 5% resistors that have been put in the amp, so that's obviously after maintenance. And then there's a lot of the 10% ones. So I'm going to go through and buzz those out and see if they're way out of tolerance. Alright, now if you look at the input over here, they actually just have straight wires that go along the chassis, and this is a source of noise. So I promised the owner that I'd put some coax in here, and that'll cut down on some of the input hum and buzz. Alright, now this socket I mentioned, this black one, it really looks original. I really can't see, unless somebody did a great job, that it's been replaced. So maybe Fender just ran out of the brown ones. I don't know. But at this point, I really don't see any bad connections. So the next thing I want to do is pop around a scope. We'll do the old tug test on things. Just kind of go through and bump components and see if there's any sensitivity. Alright, so at this point, got my scope hooked up to the speaker output jack with a 4 ohm dummy load. We're on AC coupling, 50 millivolts per division. You can see our noise level. Looks nice, right? I don't see any activity. Volume controls are all the way down. Now what I'm going to do is take this little plastic wand and just go through and start pushing on components. And if I see something that makes a scope jump, then that could be a suspect issue, right? Oh, look at that guy. It's not bad, but it's definitely sensitive. Look, I just rubbed my probe on it. So that could be one, right? So that's a disc capacitor. Keep on going down here. So I'm really not seeing anything. Now remember, these ground runners going to the front, you need to check those. They're kind of notorious for having issues. Okay. So you hit those and make sure that they're okay. I inspected them, they look good. Now take a look at the scope. I don't know if you can see it. We have a little bit more noise activity. So I've pulled all the shields off the preamp tubes. So I'm going to go through, just kind of tunk on them a little bit, just to see if we have some sensitivity. Right there, you see that? There's a little bit on that guy. This is V3. So he is a little sensitive. Here's the output tubes. They appear to be fine. So the one that I'm wondering about right now is V3. Okay? And that's not going to the black tube socket. Okay? So the two things I need to look at are all the connections on V3 and then this disc cap here, which appears to be very sensitive. It's almost like a little microphone. So I think we're going to change those. Anyway, let me get my soldering iron hooked up and we'll get rolling on that. Alright, so those two ceramic capacitors that you saw on the chassis are both 0.01 microfarad caps. Alright, so we're going to change them out with these Sprague orange drops and see if that solves our noise sensitivity issue that we're seeing. Alright, and I'm going to do that with my new Hakko solder station. So let me zero in on these guys and show you my old one versus the new one and why I'm going to use that for this repair. So here's the old workhorse, my Hakko 936 that you guys have seen in pretty much all of my videos. I've had this thing about 10 years at least. Great station. Problem is, they're obsolete now. And I was actually looking for another one as a backup because this was my only station. And I thought, man, if I'm in the middle of a repair and that thing dies, I'm hosed, right? Well, I was finding, like on eBay and other places, that the used ones are as much as buying the new replacement station, which is the Hakko FX 951. So you can see this one's a little fancier. It's got a digital readout. The little solder cleaner, the tip cleaner, is built right into the base, which makes it nice because this one here came with the old sponge that I never used. So I had one of these little steel wool guys, but it was always all over my bench and I couldn't get to it, and I'd stumble on and knock it over and there'd be solder particles all over my bench, right? It was kind of a mess. So I thought, alright, you know, you guys have been cool. You've been sending D-Lab some little donations and things. So this is what the donations did for me. Bought a nice new solder station. So we're going to use it to repair the first amp, which is the Fender Bassman. How cool is that? As a precaution, before you get in here and start soldering, take your meter and DC volts. Make sure the power supplies are dead, right? Because you don't want a little surprise. And being a solid state rectifier like this thing is, sometimes those caps stay charged much longer. So I always check that first. Alright, let's get those caps pulled. So here goes. First solder job with the Hakko. Got my tip set at just a little bit over 700 degrees. When you buy the station, it comes stock set at 750, which is a little bit too aggressive, I believe, for these type connections. Anyway, the old cap's out. I'm going to get these leads formed and get the new one in. That old orange drop looks a lot nicer than those big old ceramic, doesn't it? And you know, the other thing about these ceramic caps is you normally see these used like in RF applications, where for audio you normally see these type of caps. Alright, there's the ceramic caps, been pulled. Spragues are in their place. Let's see now if we have that sensitivity. Scope is just staying straight line. I don't see anything now. So that was one source of the noise, and you're not going to see that on a capacitor tester. You can only see that on a scope. So one source of the noise has been eliminated. Now I'm not going to do a little dance here because I don't believe it's completely fixed, right? I have other things that I want to check. So now what I'm going to do is change out those red caps. Even though they're not causing problems, the owner wants them out, and I agree. So I'm going to change those. We're going to put in new coupling caps to the output tubes. Then we'll put it on the scope and take a look at that signal. And then if you'd like, I'll hook the speaker back up and we'll see if all the hissy poppy and little birdies are gone. How's that? Alright, so the red uglies are out. Now before I change these coupling caps, for the fun of it, let's do an A-B comparison. So right now I have about negative 49.6 volts going to the grids of the output tubes. So let's imagine that there's already leakage in these caps, alright, which would change the negative bias, but you can compensate for that with the bias control, correct? So if I were to put in the new Spragues and that bias change dramatically, then we can assume that there was already some DC leakage through those caps. Hopefully when I change them they'll stay at that voltage, but if I have to readjust everything, then we can assume that that failure was ready to happen. So by the way, in case you're wondering, these are the Sprague 715P series, rated at 600 volts. So this is the beauty of these eyelet connections, is you can easily change components from the top side. Can you imagine if you're doing this on a circuit board? So there's the old blue Ajaxers out of the scene. Got the Spragues installed. The Hayco is working like a dream. I'm loving it. The heat stays constant on the tip. This thing is really nice. If you guys have an opportunity to pick up one of these new FX series Haycos, I'd highly recommend it. And thanks again everybody for contributing to D-Lab. It makes my job that much easier. Alright, let's fire this thing up and see what that negative voltage did, right? So I'm going to put my meteoroid on here, plug him in. There's the negative voltage right back to 49 volts. Look at there, she went to a little over 50. It's probably my connection. There we are. 49.8. Go up here. Very slight change, but nothing alarming. So I would say that the old Ajax caps that were in there were okay, but as a precaution, it's always good to change them. Alright, so we've changed out a lot of caps, right? So we know that we had sensitivity up here before. Now she's nice and dead as a doornail. That's what I like to see. I don't like to tap on things and watch that scope go nuts, because that's always noise, right? Now remember we had that tube, which was V3 here. He still has a little bit of noise, whereas the other ones are really hammering on the preamp tube, but you would expect that because that is the input preamp tube, right? But all in all, I would say these tubes are okay. Now the other thing is the owner gave me a complete new set of tubes that he wants to install, right? But before I do that, we're going to add the master volume on the back of the amp that he wanted, and that will go in the place of the AC socket, which is, zoom down here, it's sitting right there. So the line cord goes to that. Okay, so I'm going to remove that socket. We're going to add a master volume control and test this amp while we have the old tubes in it. That way if something goes wrong, I won't smoke his new tubes. Alright, the game plan is we're going to remove this AC socket, which nobody uses anyway. I'm going to add a aluminum plate inside to mount this dual 250K pot, and this will be our master volume. These are really handy for running a higher power amp at lower volumes for recording. It lowers your noise levels, right? So it's a nice option, and it really doesn't hurt the value of the amplifier at all. If anything, it increases it. So you need this pot and two 2.2 meg resistors. You can see this circuit on Triode Electronics. Alright, this is not hocus pocus here. It's well documented on their site. The other thing you want to use is good shielded cable. This is RG174. Alright, so this will go to the grids of the output tubes, because now you're going to be extending these lines here that normally go direct to the tubes. You're going to come over here and go back. So there is a chance of noise, right? So that's why you should use coax. The other thing I need to warn you about is because these tubes have feedback, if you get these grid lines reversed, you're going to have an uncontrollable amp, and it could possibly damage the output tubes. Do it one at a time. Make sure that the wire that's coming off this grid cap goes to the proper tube, and so on with this one, right? Don't cross them or you have problems. So this is a post inverter master volume circuit, so it has no effect on the tone quality of the amp. It is the circuit to use. So the outlet's pulled, and you can see this was just a two-prong outlet, no ground. Old school, right? Now you're going to cut yourself a piece of aluminum. This measures approximately 2 1/4 wide by 1.5 inches high. And we'll put that in here. And we'll drill and mount that plate. Then I'll drill a hole here for the shaft of the pot to come through. And when we're all done, we'll have a little skirted fender knob on there. So it looked pretty much stock. Well, there's the new Master Volume pot installed. I reused those old original self-tapping screws, and you can see the terminals are facing up. You gotta have them facing up or you're not gonna be able to solder to them, right? So the next step is get the resistors installed and the shielded cable, and then we need to re-terminate the AC line. Master volume control wiring is complete on the pot itself. You can see it gets pretty busy here, right? Now if you look at these blue wires, I'll set this where you can see it. The blue wires are actually going to the shields of all the coaxes, right? They're not very clear about that on triode instructions. And the blue wire is also your negative bias voltage coming off of the 10K bias pot, alright? And the reason that they come into the pot and connect those shields to that same negative bias, it is a form of common mode noise rejection. So that's why you have to use coax, and you have to take the additional time to hook all those shields up to the negative bias line, like I've done here. So this is the hard part. After that, you simply connect these two coaxes to the grids of the output tubes, and these two go over here onto the coupling caps. I've removed the 220K resistors, and then the bias pot itself now feeds the master volume pot. So before you connect these coaxes, like I said before, you got to pay attention and make sure that you do not reverse their orientation, right? So if you look at the instructions on Triode's site, you'll see they mark them G1, G2, G3, and G4. G1 and G2 go up here to these two caps. G3 and G4 go to the tubes. If you look at the schematic, you'll see that G1 goes through the pot and goes to G3, and G2 goes through the other side of this pot to G4. Make sure that you got that lined up before you solder it up. Wiring of the master volume control is complete. So here are a few things you must check before you apply power to this amp. Remember, if you didn't get this hooked up correctly, you're going to lose negative bias to those output tubes, and they're going to go up in flames, right? So this is very important that you check these things. First thing, put your control all the way clockwise, so it's at 10, alright? When you do that, it's actually going to connect G1 to G3, G2 to G4, because the wiper now makes contact from the center to this side, alright? So if I take my meteoroid and I go from here to here, you'll see a little under 2 ohms. We'll call that continuity, alright? So we know now that this wiper is in the advanced position where I should have pretty much continuity from G1 to G3. Now G3 is going down here to the first output tube. There it is. That's good. Now if I go to G2, that should be going to G4. Alright, so that tells you right there that you have your grid connections correct. You don't want to see continuity from G1 to G2. Okay? Now, there's some other things you want to check. Number one, remember how you took the shields of these coaxes and you tied all them together and you tied them to the bias line? Okay, make sure you didn't accidentally tie the shields to ground, or you'd be taking your negative bias to ground, and that'd be very bad. So what we're going to do, we're going to take our meteoroid and we're going to go to chassis. Make sure that works. Yep. Now you're going to buzz out every one of these wires to ground, and you should not see any continuity. Okay, so it's just a quick check. Make sure that nothing is going to ground. Okay, so that tells you everything's cool here. Now we know that the shield plus one side of these pots is tied together. We also know that this is a negative bias line that goes over here to the center of the 10K bias pot. Okay, if I can get my meter to cooperate with me. Come on, meter. You guys think the D-Lab did it wrong, don't you? There we go. Alright, so we have continuity from our bias pot, through these leads, to the grids of the output tubes. So at this point, you should be safe to go ahead and apply power, and then we're going to recheck the bias on those tubes, make sure nothing changed, which it shouldn't have. So for the initial test of your master volume pot, you want to turn the amp on, but keep your standby off, because at this point we want to make sure that we have the proper negative bias to those two output tubes. Alright, so I have my meter connected to the grid of the first output tube. Standby off, power's on. I'm going to plug it in. And there we are, that negative 50 volts. Remember, we saw that initially. So that's a good sign. Let's check this tube. Yes, so they're both present. The other thing you want to do is take your master volume pot and turn it, and make sure that it does not affect that negative bias, because if it does, you wired it wrong. So at this point we're ready to do a full test and throw some audio through this thing. Alright, here we go. I've applied a signal now to the amplifier at about 500 hertz. Alright, master volume right now is all the way up. Turn up the volume, you can watch it on the scope. I'm going to back off on the master volume, and of course the input volume still works, but the master now gives you control over the grids to the output tubes. So that's the best of both worlds, and it looks nice and clean. So the advantage of this, I'm going to take off my input. Let's take our millivolts down to 0.1. Volume's all the way down. Bring my master up. You can see our noise floor. Now if I were to take the master back, you can kill that noise floor. So if you're playing at lower volumes, you can get cleaner sound. If you don't need that amp to put out full bore, now you can throttle it back with a master volume and have much cleaner tones for what you're recording. So there are a few techniques that you can utilize for reducing noise in your amplifier. Obviously the first thing is see if you have bad tubes or components that can generate the noise. Secondly, once you know that all that's good, you can add yourself a master volume to throttle down that noise. If you're going to run that amp at 10 watts for recording, why do you need the full 40 watt output, right? So you attenuate the grids a little bit to the output tubes and get a cleaner sound. What a deal. Just make sure that you're very cautious when you hook it up. Hope you enjoyed it. We'll see you again.